Okay, so we're ready to go. So the first thing we're going to discuss are vertical and horizontal asymptotes. So a vertical asymptote is a vertical line that the function, and the function here is the purple graph. It's the same function. That's a little bit hard to see. It's the function f of x is equal to 1 over x. So that's the graph, the purple graph here. It has two branches to it, but it's still the same function. The vertical asymptote is the vertical line that the function gets closer and closer to, but it never touches. Okay? So a vertical asymptote occurs whenever the denominator is equal to 0. Okay? So because you can never divide anything in math by 0, the function's undefined there. So to find the vertical asymptote, which I'm going to use VA to short form vertical asymptote, set the denominator equal to 0. Now, not always when the denominator is equal to 0 will you get a vertical asymptote. Okay? In this class, yes. If you go on to calculus and anybody going on to university, there's other things that can happen. You can have holes in the graphs. You can have oblique asymptotes. There's a whole bunch of different things. But for our purposes, whenever the denominator is equal to 0, you're going to get a vertical asymptote. So when I set the denominator equal to 0, I get x equal to 0, and I get my vertical asymptote. So my vertical asymptote is that vertical line that the function gets closer and closer to but never touches. So that's my vertical asymptote. What I want to be able to do ultimately, again, is figure this all out algebraically without using the graph. And also, I want to figure out where the function is heading towards as it approaches a vertical asymptote. So when a function approaches a vertical asymptote, so as it starts approaching the red line, it has two choices. It can either go down or it can go up. That's the only two things it can do. Okay? So I want to be able to figure this out algebraically, ultimately, but I'm just going to show you the notation from using this graph right here. So I want to say, as I'm approaching from the left-hand side. Okay, so to say that mathematically, I'm approaching the value 0, but I'm approaching it from the left-hand side, so we put a little superscript with a negative sign. So that all that means is I'm approaching 0 from the left-hand side. Okay? So as I approach 0 from the left-hand side, I'm taking different values for x. So if x is this value, my function value would be here. If x is here, my function value would be here. If x is here, my function value is here. If x is here, my function value is here. As I get closer and closer to 0, I have to go further and further down to touch my graph. Okay? So what's happening is my function is heading towards negative infinity. Does that make sense, what we're talking about? So that's the notation for writing. As I approach 0 on the left-hand side, I need to go downwards in order to touch my function. Okay? Then there's the other side of the asymptote. There's the right side of it. So we put a little superscript with a plus sign. So this means on the right-hand side of 0. So as I approach on the right-hand side of 0, you can see my purple graph is heading upwards, and it's heading upwards forever. So we say that it's heading towards positive. So what I wanted to show there is remind you what a vertical asymptote is, and show you this new notation. Okay? Because in the next example, we're going to figure this all out algebraically without having the graph. Any questions on that? Horizontal asymptotes. Horizontal asymptotes are horizontal lines that the function gets closer and closer to as x heads out towards negative infinity and as x heads out towards positive infinity. So from the graph here, you can see that the horizontal asymptote is the x-axis, and the equation of the x-axis is y is equal to 0. I'm going to show you a way to figure this out algebraically, okay? But from now we can just see from the graph. Horizontal asymptotes are a little bit different than vertical asymptotes in terms of, one, they're horizontal instead of vertical, but also a graph will never ever cross a vertical asymptote, but it can cross a horizontal asymptote. It could cross it a bunch of times, in near here. A horizontal asymptote is what's happening out at the extremes, out here and out here. So you can see way out here in the extreme that my purple graph is getting closer and closer to my green line. And over here, my purple graph is getting closer and closer to the green line. Okay? So the way that I'm going to write this is as x approaches negative infinity, so as I'm way out here, my purple graph is getting closer and closer to 0. And on the other side, as x approaches positive infinity, my purple graph is getting closer and closer to 0. So this is just some notation. And then we're going to use this now to identify the vertical asymptotes and the horizontal asymptotes when I give you the equation instead of just the equation in the graph. Example, determine the vertical asymptote and horizontal asymptotes of the function f of x is equal to 2x minus 3 over 4x minus 8. Okay, so what we're going to do is we're going to determine the equation of the vertical asymptote. And that's pretty easy to do. All you have to do is set the denominator equal to 0. Okay? And then you'll get the equation of the vertical asymptote. This part is going to take a little bit of understanding and thinking. So, to determine the vertical asymptote is when you set the denominator equal to 0 and you solve. So x equal to 2 is my vertical asymptote. Now I want to figure out, because my function, so if I graph this, I just figured out x equal to 2 is my vertical asymptote. So I'm going to have a function, right? And my function is going to come along and it's going to approach from the left-hand side, and then it either has to head upwards or downwards. And as it approaches from the right-hand side, it has to head upwards or downwards. We're going to figure this out now algebraically. Okay? So I want to know where my function is heading towards on the left-hand side of 2. So on the left-hand side of 2, which is over here, I want to figure out what my function is heading towards. So my function is heading towards, it either has to head towards up or down. So it has to head towards positive or negative infinity. And then I want to do it from the right-hand side. So in order to figure out where it's going, we're just going to use some simple algebra. I'm going to take a number on the left-hand side of 2. So here's 2. A number on the left-hand side of 2, which is pretty close to it, is 1.9. Everybody hear that? I'm going to take 1.9, and I'm going to substitute it into my function and see if my function's positive or negative. And that'll tell me where it's going towards. So 1.9 times 2 minus 3. Will that answer be positive or negative? And if you're not sure, you can always do this in your calculator. But 1.9 times 2 minus 3, positive or negative, anybody? Yep. Positive. Positive. 1.9 times 4 minus 8. Is that going to be positive or negative? So because 1.9 times 4 is going to be less than 8, right? All right. Right? And then subtract off 8 is going to be negative, right? So then a positive divided by a negative is negative, so it's heading towards negative infinity. Now I'm going to figure out where it's heading towards on the right-hand side of 2. So on the right-hand side of 2, I'm going to use a number close to 2. That's on the right-hand side of it, which is 2.1. 2.1 times 2 minus 3 is going to be a positive answer. 2.1 times 4 is going to be bigger than 8. When I subtract off 8, it's still going to be a positive. So a positive divided by a positive is a positive, which tells me it's going towards positive infinity. So what this told me now is that my function which I'm doing here in green. On the left-hand side of 2, it was going towards negative infinity, and on the right-hand side, it was going towards positive infinity. Ultimately, what that's going to help me do is sketch the graph when we need to sketch it. Does that make sense, what I've done? Okay. So that's all there is for determining the vertical asymptote. Okay? Horizontal asymptote. Horizontal asymptote of the function in order to understand how to determine the horizontal asymptote, we have to understand this concept. Okay? As x approaches positive infinity, so all that means is as x gets larger and larger, so as x becomes 10, 1,000, a million, 100 million, a billion, right? What would the value of 1 over x become? So as x becomes larger and larger, what would 1 over x head towards? 0, right? Because when you take 1 and divide it by 10, you'll get a decimal number. You take 1 divided by a million, you're going to get a decimal number, but it's much smaller. Divided by a billion, it's going to be even smaller. Does that make sense, that concept? Okay, so what happens if I was on the left-hand side of it, if I chose negative numbers? As x approaches negative infinity, what would 1 over x approach? Yeah, also 0. Just wouldn't matter, just because the decimals would be negative. So really what I can do, and in this class only, because it doesn't always work like that, is I can be lazy and say as x approaches positive and negative infinity, 1 over x is approaching 0. So as x approaches positive and negative infinity, what would 5 divided by x approach? Anybody else? Can you follow along? If I take 5 and divide it by a number, and I take 5 and divide it by a bigger number, if I take 5 and divide it by an even bigger number, it's going to head towards 0. So really, it doesn't matter what number's on the top. It could be any number in the world. If I divide it by a number that's getting bigger and bigger, the decimal is going to get smaller and smaller, and eventually it's going to get so small I can see it's equal to 0. Does that make sense? Because in order to figure out the horizontal asymptote, we're going to have to use this concept. So to determine the horizontal asymptote, the first step is to divide the expression by the highest power of x. So you look at your expression, which is 2x minus 3 over 4x minus 8. The highest power of x is x to the power 1. So I'm going to divide all terms by x to the power 1, or just x. 2x divided by x minus 3 divided by x over 4x divided by x minus 8 divided by x. I can do that because really what I'm doing is I'm multiplying by x divided by x, and x divided by x is 1. So I'm not changing the value of anything, I'm just changing the look. Okay, once I've done that, my next step is to simplify. So to simplify, 2x divided by x is 2. 3 divided by x can't be simplified, so I just leave it. 4x divided by x is 4. And negative 8 over x can't be simplified, so I read it like that. But now I have it in a form in which I can identify the horizontal asymptote. So now I'm going to say as x approaches positive and negative infinity, what is this approaching? What is 2 minus 3 over x over 4 minus 8 over x approaching? Okay, so excuse me. As x gets really, really big, in the positive direction and the negative direction. Were you going to ask me something? No. This 2 is being unaffected by the x. It doesn't have an x near it, so it's not going to be affected by it, so it's staying 2. But what is negative 3 over x becoming? What value? David? Who said the 0? Nick? Did you say it? Okay. Why is it becoming 0? Yeah, so that thing in the top corner that I just talked about, that I assume everybody understood, because nobody said, what are you talking about, Hoffman, right? So as x gets bigger and bigger, I'm taking 3 and dividing it by a bigger number each time. So the decimal's getting smaller and smaller. So if I keep doing that, it's going to head towards 0. But the 2 is unaffected because it doesn't have an x near it, right? Likewise, in the bottom, the 4 doesn't have an x near it, so it's unaffected. It's going to stay 4. But the 8 over x is going to head towards 0. So this looks like this is heading towards 2 minus 0, which is 2. 4 minus 0, which is 4. And 2 divided by 4 is 1/2. So it's heading towards a value of 1/2. Therefore, the horizontal asymptote is the line y is equal to 1/2. So if I graph this thing, right, it should have a vertical asymptote at x equal to 2. And on the right-hand side, it should go up towards positive infinity. And on the left-hand side, it should go down towards negative infinity. And it should have a horizontal asymptote of y is equal to 2. That means that we're going to have a horizontal line that the function is going to get closer and closer to. So if I graph it, divided by 4x minus 8. There's the graph of it. And you can see here it has a vertical asymptote at x equal to 2. There's my value 2. And on the right-hand side, it went up to positive infinity. And on the left-hand side, it went down to negative infinity. We found that algebraically. And also, right here is the value 1/2. And you can see if I drew an imaginary line here, actually, if I plot that, 0.5 is 1/2. You can see that it's a line that the function is getting closer and closer to. Okay, so now we found the horizontal asymptote algebraically. We found the vertical asymptote algebraically. We figured out where the function was going on the left and the right-hand side of the vertical asymptote. We're going to use all this information to answer questions like this. Okay, so like I said before, this will be very similar to your test questions. The only difference is that the numbers in the expression are going to change. That's the only difference. Okay, so this is a typical example of a rational expression. First thing you're asked to find is the vertical asymptote. So the vertical asymptote is easily found. You just take the denominator and set it equal to 0. So x equal to -5 is the vertical asymptote. Now, the next part I'm going to do, because it's going to help me ultimately sketch the graph, and that's what I'm going to need to do to sketch the graph. So as x approaches -5 from the left-hand side, I want to figure out where the function's heading towards. And as x approaches -5 from the right-hand side, where is my function heading towards? Remember, it only has two options. It's either up or down. So you take a point on the left-hand side of -5. So something on the left-hand side of -5 would be -5.1. If I put -5.1 times it by 2, subtract off 4, it's going to be negative. If I put -5.1 and add 5, it's going to be negative. And negative divided by negative is a positive. So it's heading towards positive infinity on the left-hand side. And on the right-hand side, I can use -4.9. Negative 4.9 times 2 minus 4 is a negative. Negative 4.9 plus 5 is a positive. A negative divided by a positive is a negative. So I just figured out where the vertical asymptote is, and I figured out on the left-hand side it's going upwards, and on the right-hand side it's going downwards. The horizontal asymptote. To figure out the horizontal asymptote, I need to divide everything by the highest power of x. So 2x divided by x minus 4 divided by x over x divided by x plus 5 divided by x. Then I simplify. 2 minus 4 over x, 1 plus 5 over x. Once I have it in that form, now I can figure out the horizontal asymptote by saying as x approaches positive and negative infinity, then 2 doesn't change, but 4 divided by x is going to go towards 0. 1 doesn't change, but 5 divided by x is going to head towards 0. 2 minus 0 is 2. 1 minus plus 0 is 1. So that's heading towards a value of 2. Therefore, and you have to write this, the equation is y is equal to 2. Most people do extremely well in the first 2 pages of the test. I would say 50% of people lose marks because they don't write y is equal to 2. Okay, you have to write the equation of the asymptote. Okay. The domain are the x values, right? Here's my x values up here. The domain is always going to be x is an element of the real numbers, except where x is undefined, which is at the vertical asymptote. So this negative 5, and that will always match. Same with the horizontal asymptote. The horizontal asymptote will help you figure out the range. The range is an element of the real numbers, except at the horizontal asymptote, which is equal to 2. Okay, so all this means is x will never be equal to negative 5, and here y will be never equal to 2. The intercepts. To find the intercepts, just like back in grade 9, to find the intercept, the y-intercept, you'd set x equal to 0. And to find the x-intercept, you'd set y equal to 0. So to figure out the y-intercept, I use my function. Remember that f of x and y are interchangeable. So to figure out my y-intercept, I put 0 in for x. Do some math. And my y-intercept is negative 4 over 5. My x-intercept is when y is equal to 0. So I have to solve this equation here. The only time a fraction, because this is a fraction, a rational expression, is equal to 0 is when the top is equal to 0. Because when the bottom is equal to 0, it's undefined and you can't do it. So really you're only concerned about solving this part right here. When is the numerator equal to 0? So the numerator is equal to 0 when x is equal to 2. So we found the vertical asymptote, and then we found what the function is doing on either side of the asymptote. We found the horizontal asymptote. We found the intercepts for both the y and the x-intercept. Now we should have enough information to sketch it. Okay? So the first thing I'm going to sketch are the asymptotes. X equal to negative 5. 1, 2, 3, 4, negative 5. So I'm going to put in a vertical line for the vertical asymptote. And a horizontal line at the horizontal asymptote. So this was x is equal to negative 5, and this was y was equal to 2. I'm going to draw in the little piece of the function on either side of the asymptote. So on the left-hand side of -5, we know it's heading upwards. And on the right-hand side, it's heading downwards. And I also know that it has an x-intercept at 2. And it has a y-intercept at -4 or 5, which is approximately just below -1. That makes sense? So now I'm just going to use what I know about functions in order to graph it. Because really I have enough information. All of these rational functions are going to look like this. You're going to have 2 branches to it. Okay, one branch on the left side of the vertical asymptote and one branch on the right side of the vertical asymptote. So if my function heads downwards here and then has to pass through here and here and then get closer and closer to the horizontal asymptote, the only way I could sketch it would be like that. Does that make sense? And if you're unsure, right, if you're really unsure what's happening, you can always just take some x values, like x equal to 10, plug it in here and get some points if you needed to. Okay? So that's the one branch. What do you think the other branch looks like on the other side, the left side? Okay, so when you say mirror image of it, it's going to come down, and then what's it going to do right now? Right. Right, it's going to curve towards the horizontal asymptote. Okay. Any questions on that? So your boundaries are your vertical and your horizontal asymptotes would help you draw it. Your intercepts will also help you draw it. And then figuring out what it's doing on the either side of it will also help you draw it. Once you've drawn the graph, then you're going to answer these questions here. When is the graph positive? Okay, so what are the positive intervals? When is the graph negative? And then when is the graph increasing and when is the graph decreasing? So let's talk about where it's positive and where it's negative. So what I'm going to do is I'm going to kind of color code it. The graph is negative when it's below the x-axis. Okay, so here's my x-axis. It's below the x-axis here. And it's positive when it's above the x-axis. So here and here. So looking at the positive one, I want to figure out between what x values is my graph positive. So between what x values is my graph positive? Let's do this one. Between what x values is this guy above the x-axis? What values would you say? Here? So all of them, so everything. So if I say at -3, the graph's above the x-axis, it doesn't, so it gets at all of them, right? So I want to say between, so my function here is above the x-axis here. So between what values are these? What value is this? And then this keeps going on forever. Lucas? Perfect. Okay, because it's always from -infinity. And then it stays positive up until it hits -5, but it doesn't include it, so I need to put round brackets around it. When's the next time it's positive? Between what values?
Between 2 and positive.
Perfect. So right at 2 again, that's where it's equal to 0, but beyond 2, it's above the x-axis. So between here and all the way from here. Okay. When is the function negative? When is it below the x-axis? Between what x values? Lucas? Right, so from here to here, you can see that the function's below, so we write that as -5 to 2. Again, remember, if you don't like this bracket notation, you can always write x is greater than -5, x is less than 2, x is less than -5, x is greater than 2. Whichever way you want to write it, you can write it down. Okay, but all you're looking at is between what x value, so you're looking this way, is the graph positive, so between here and here, between here and here it's positive, and when is it negative? Between here and here. And you're just writing down those x values, so like boundaries. Look at this. No, because that's when it's equal to 0, and I asked when it's positive, which means plus and when it's negative. Okay? And in fact, if you do include it, I'm going to mark it wrong. It's equal to 0. Okay, so just remember that a graph is increasing when it goes up to the right, and it's decreasing when it goes down to the right. So what intervals is this function increasing? How do I try?
Well, it's always increasing. So
Except at what value? What's the only value it's not increasing at? It's not defined yet. Exactly, which is
2
Nope.
or -5.
Negative 5. Perfect. So you'd say it's always increasing on every x except when x is negative 5. So when's it decreasing? If it's always increasing, then when's it decreasing? How? Yeah, exactly. So, perfect. You can. But this is just like set notation, really. I should write down like this. X such that x is a real number, x is not equal to negative 5. Okay? Or another way of writing it would be from negative infinity to negative 5, and from negative 5 to positive infinity. You can write it like that in notation as well. So, again, exactly. The only thing that's going to change are these numbers up here. You have to identify the vertical asymptote, the horizontal asymptote, the domain, the range, the intercepts, and sketch it, and then answer these questions from after you sketch it. Okay? Most people forget to write y is equal to for the horizontal asymptote, and for some reason people mess up this part as well. If you're unsure about what I'm talking about, feel free to ask me. I can do another example for you. Okay? Okay. So I'm going to save this.